TESS has an incredibly wide field of view. It actually covers about 2,300 square degrees of sky every time it takes an image. This is a band that's about 24 degrees wide by 96 degrees tall, and the fields of view are broken up into 4 cameras, each of which are 24 degrees on the side. So it's an absolutely enormous chunk of sky that we view at any given time. And then because of the way the TESS orbit was configured, we basically step around the sky and do the sky as if it were slices from an orange. And the number of slices that are in this configuration of sky mapping that we come up to is 13 per year. And that's because there are 13 lunar months per year, and that relates to the way the satellite is synchronized with the moon. So with that information, we can cover the entire sky, but first the northern hemisphere and then the southern hemisphere in 2 years' time. And then as a result of that, and the 2 full sky surveys that we've done to date, we've been able to observe more than 100 million stars for the possibility that they have planets. And thus far, we've detected almost 6,000 candidates for planets, of which approximately 500 have had their masses established by spectroscopic measurements that are largely made on the ground and also from space. So that's the major yield of the satellite so far. And because for every year and every revisit that we do to the sky, we're finding periods that are longer and longer because we've gotten more samples. We find many more stars that have planets. And then as a result of that, we expect the number of planets per year, new planets that we find, to increase by about 1,500 per year as the mission goes on. So it's 1,500 per year. So for the new mission, the new 3-year period, we're talking about another 6,000. And then if we continue operating from 2025 to 2028, that's another 6,000. And the satellite will actually continue at this rate probably for more than a decade. So it really is a census of the sky in a unique way that has never been possible before. And then what we find from these planets is basically they provide the targets for missions like the Webb telescope that was just launched, who can study either the masses of those new planets that we've seen, because the transit observation only tells you how big the planet is. It is in terms of its diameter. It does not tell you what its mass is. It does not tell you about its atmosphere. But if you know where the planets actually are, and you know approximately where they are relative to their host star, then you can make, in some cases, theoretical estimates, but in many cases, definitive estimates of the properties of them. You can tell whether it's what we call a water world, or it's a rocky planet. And you can also, as you look at different types of stars, you can see whether there are multiple planets around those stars. For example, we found some systems that have as many as 6 planets orbiting around them, and basically the search goes on for the systems that we've already found. And so this is one of the key results from the TESS satellite, and it's been essential that the instruments be high reliability and that they operate in a very stable way for years at a time. And that's one of the things that we're most proud of in the way that we built and operate the satellite.